Woo! Wish you could see me dancing right now, guys. Kicking off over here. I don't know the word, but I know the song. Right. Oh my God. We're starting out with a new topic. It's called Simultaneous Equations. In a new page in your book, write the title, write the learning objective, and pause the video so you've got time to do that. Press play when you're ready to keep going. So, don't know what that was, what that intro was about. It's not going to be, it's not going to be all like that. Don't get your hopes up. But we're going to continue with this new topic. Now, I'm going to start off by giving you this equation here: 3x plus 5 equals, let's say, 14, something like that. Now, if I ask you to solve that equation, I'm sure you'd be able to do it. Pause the video and say in your head the steps that you would do to solve that equation. Well, hopefully you said, first of all, I'd take away 5 to eliminate the plus 5. Do it to one side, do it to the other. And then you'd say, divide by 3 to eliminate the times by 3, and do it to one side, do it to the other. So what that means is x equals 3. That is the value that x would have to be in order for this to be true. So let's just check. We do 3 brackets 3 plus 5 equals 14. 9 plus 5 equals 14. 14 equals 14. You know that's right. That is the unique solution to that equation. That's all basic revision from like year 8 maybe. We've been doing that for years. What about this situation here? Here we've got x plus y equals 8. If I asked you to solve that equation, which means if I asked you to find the values of x and y that made that equation work, that made it true, what would you say? Some of you might be saying that x equals 5 and that y equals 3. And that would work. But others of you might be saying that x equals 4 and y equals 4. And that would work. Some of you might be saying 2 plus 6, that makes 8. And I would say you're right. And you might even go 9 plus negative 1, where x is 9 and y is negative 1. At this point, maybe you start to see that there actually aren't a specific pair of solutions for x and y. Because we could go on like this forever. We could say x was 10 and y was negative 2. We could say x was 11, y was negative 3. And we could go on and on and on forever and ever and ever. Now the reason for that is because we have one equation with two unknowns. And when we have an equation with two unknowns, it is impossible to solve that equation on its own. So I'm going to write another equation up here. 4x plus y equals 23. Now in this situation, we now have two equations, equation A and equation B. Each of those equations has two unknowns, x and y. When we have two equations and two unknowns, it is possible to solve those equations at the same time, and we call that simultaneous equations. Simultaneous is a word that means something happening at the same time. So it's possible to solve two equations with two unknowns using something called simultaneous equations. It's a strategy we're going to learn. So write that down in purple pen. Two equations, two unknowns. That's what I say. You say simultaneous equations with a smile on your face, because you're learning a new strategy for solving some maths problems. And what's not fun about that? So let's practice it. 2 equations, 2 unknowns, simultaneous equations. 2 equations, 2 unknowns, simultaneous equations. I'm not going to keep going with that, but I'm sure some of you, Corey for example, is probably just going to keep watching that like 10 more times until he's mastered the chant, because Corey loves the chants and he realizes how good they are for his maths learning. So what I'm going to show you now is the strategy that the 2 equations, 2 unknowns chant requires you to do. So you label the first equation A and the first equation B, and you draw a line underneath them. The next thing you have to do is draw this box over here. You can do a box, you can do a cloud, doesn't really matter. But you have to decide, are you going to write a plus or a minus in that box? What you have to do is you have to choose either the x's or the y's, and you have to try to eliminate them. This method for solving simultaneous equations is actually called the elimination method. If you look at the learning objective, I will learn to either add or subtract to eliminate one of the unknowns. That is what this lesson is all about. Are we going to first of all target x or y? And once we've decided which one we're going to target, how are we going to eliminate them? Are we going to add or are we going to subtract? Well, to decide that, I'm telling you now, the one that you're going to target is the one where you have the same number in front of both of the unknowns. So you can see the x's, there's a 4x and there's a 1x. Do we have the same number in front of the x's, guys? No, 4 and 1 are not the same. But do we have the same 1 in front of the y? Yes, we do. They're both 1y. So we're going to target the y's in this example. So I've got a positive y in equation A, and I've got a positive y in equation B. How can I eliminate both the y's? If I have positive 1y and another positive 1y, what do I have to do to them to eliminate them? Do I have to add or subtract? Well, let's try adding them first. 1y, positive 1y plus positive 1y, how many y's do I have? Well, I've got positive 2 y's overall. Have I eliminated the y's in that situation? No, I haven't. If I have positive 1y take away positive 1y, I've got 0 y's, or 0. So, to eliminate these 2 y's in the question, I am going to take away. I'm going to write a subtract in that box. Look back to the learning objective. I will learn to either add or subtract to eliminate one of the unknowns. In this case, I'm eliminating the positive y's by subtracting. I now have to subtract all of equation B from all of equation A, which means 4x minus x is 3x. Y minus y, positive y minus positive y, they're gone. That's the whole point. And 23 minus 8 is 15. Now I have an equation with just one unknown. And I'm sure you know how to solve this. How do I eliminate times 3? Divide by 3. Do it to one side, do it to the other. And so x, these are cancelled, so x equals 5. So that is the first of my solutions. For both of these equations, A and B, how many unknowns do they both have? That's right, they've both got 2. They've got an x and a y. So once you've solved the first unknown, the strategy is subs, as in substitute, in, and then you pick either A or B to substitute into. I'm going to pick B because it's easier, because x plus y is easier than 4x plus y. So I write out my equation B, x plus y equals 8. But I'm now going to substitute the value of x that I've come up with in place of x. So substitution, replace with brackets. So we've got 5 plus y equals 8. And then I'm going to subtract y from both sides to get y equal 3. And oh look, I've got another solution. Now I have a solution for x, and I've got a solution for y. Now if these both work, if these solutions are correct, then if I substitute them both into equation A, then equation A should be correct. It should work out nicely. So let's just check. Checks in B. Nope. What's wrong with that? Well, if I subbed in B, then I have to check in A. You've got to check in the one that you didn't substitute into first time round. So I'm going to write out equation A. And now instead of y, I'm going to substitute the value of y that I found before. And instead of x, I'm going to substitute the value of x that I found before. So instead of x, I've got brackets 5. Instead of y, I've got brackets 3. 4 times 5 is 20. 20 plus 3 is 23. And so therefore, I know that these two solutions are correct. Now what we've managed to do here is come up with specific values of x and y that work for both of equation A and equation B. I'm going to rub out all the things that aren't in purple. Apart from the ticks, because, well, you know. What's left here, stuff in purple, this is our strategy every single time we want to solve simultaneous equations. It doesn't matter what the equations are. If we've got two of them and we've got two unknowns, then we're going to do two equations, two unknowns, simultaneous equations. And we're going to write out our strategy in just like this. So let's do another example. Ooh, by the way, there won't always be a subtract there. That will change depending on what you're trying to eliminate. So if you want to write down this strategy now, it might be a good thing to do, but we're going to do another example anyway. So this one is 3y plus 5 equals 22. And this one is 3y. What am I doing? Obviously, it's not 3y plus 5y, it's 3y plus 5x equals 22. And it equals 3y plus 2x equals 16. So our aim is to find a value for both x and y. The strategy is already written in purple pen on the screen. I want you to try and pause the video now and have a go doing this on your own in your book. Press play when you're ready for me to go through it. All right, so let's do the working out in green. So the first question I ask myself is, am I trying to eliminate the y's or the x's first? Well, I said the one that you're going to eliminate first is the one that has the same number in front of both the x's, or in front of both of the unknowns. You can see the x's have got a 5 and a 2 in front of them, so we're not going for those. The y's have got a 3 in front of them, so that is what we're going to target to eliminate. And when there's no sign in front of both of them, we know they're both positive. So I've got a 3y and I've got another 3y, or a positive 3y and another positive 3y. If I add this and this, what will I get? Obviously 6y. So I'm not going to be adding because that's not going to eliminate them. Instead, I'm doing take away, because 3y take away 3y is obviously 0, and that is my aim. So I'm going to, again, in this example, take away. If you weren't sure about that, make a note now. Press play when you're ready to keep watching. So, 3y take away 3y, they're gone. That's the whole point. Positive 5x, take away positive 2x. That is just 5x take away 2x, which is 3x. 22 take away 16, that's 6. Hopefully it's clear to you how to solve the equation from here. So x equals 2. That's the first of my solutions. What I need to do now is I need to go over and substitute into, I should have rubbed this out before, one of A or B. We can choose whichever one we want. Whichever one we choose here for the subs in, we're going to pick the other one for the checks in. So I'm looking at these. I reckon it's probably easier to subs into B again because they're smaller numbers. Do that in green. So we've got 3y plus 2x equals 16. But rather than x, I'm going to substitute the solution that I just found. So 3y plus 2 bracket 2 equals 16. That is 3y plus 4 equals 16. Take away 4 from both sides, and I get 3y equal to 12. And divide both sides by 3, and I get y equal to 4. That's the second of my solutions. But the beauty of this method is that now we get to check to see if we're right. So if I subbed into B, I check in A. I say subs in B, you say checks in A. Subs in B, checks in A. Subs in B, checks in A. Let's do it the other way around. I say subs in A, you say checks in B. Subs in A, checks in B. Subs in A, checks in B. Awkward if you're just watching me do that on the screen there, but yeah, whatever. Hope you enjoyed the show. Right, so we've got Y and we've got X. If I subs in B, checks in A. So this time I write out my equation A, 3y plus 5x equals 22. But instead of y, I write my solution for y, which is 4. And instead of x, I write my solution for x, which is 2. If I've done this correctly, then this side will equal this side. So I've got 12 plus 10. 22 does equal 22. So at that point, I get my purple pen out and give myself a tick because I've done it correctly. Well done, me. Pause the video and make any notes that you need to. If you got that correct, superb. Hopefully you get the next ones correct as well. Press play when you're ready to keep watching. All right, next one we're going to go for is this one here. I want you to solve these two equations simultaneously. Pause the video and have a go at doing this now. All right, so two equations, equation A and equation B. We've got two unknowns. What are we going to do? Simultaneous equations. So I'm writing this out. I draw my box over here. And it's all about deciding which of X or Y we're going to get rid of first. So I said we're going to eliminate the one where there's the same number in front of it for both equations. Well, the X's have got a 1 and a 3, so that's not the same. So the Y's, we've got 1 and 1. It doesn't matter that one of the Y's is positive and one of the Y's is negative, because we're going to still manage to eliminate them by picking the right thing inside this box. We're going to pick either a plus or a minus, add or subtract, in order to eliminate these two things. So If I've got positive 1y, in other words 1y, and I've got a negative 1y over here, what do I have to do to them to eliminate them? Let's try taking away first. 1y, take away negative 1y. Well, taking away a negative is the same as adding. So that would be the same as 2y. Is that what I wanted? No, it isn't. So I know that I'm not going to be subtracting. Let's try a different way. 1y plus negative 1y. I start off with 1y. If I'm adding a negative, it's the same as subtracting. So 1y take away 1y, 0. That is what I was aiming for. So that means the thing that's going in this box is going to have to be this plus over here. So I'm going to write that in green pen. Then I add all of A to all of B. X plus 3x is 4x. Y plus negative y cancelled. That was the whole point. 3 plus 17 is 20. To solve this now, I divide by 4 and I get x equal to 5. So this question is different to the other question because this time we are having to add, not subtract, to eliminate one of the unknowns. But I'm not yet finished. I now need to find what y is. So I'm hoping, like me, you picked subs in A. A is much easier than B because it's all positive and there's only one x and one y. So I write out equation A, but I substitute my value of x that I figured out in place of x. So 5 plus y equals 3, and therefore y equals, take away 5 from both sides, negative 2. But if I subs in A, I checks in B. Subs in A, checks in B. Subs in B, checks in A. So I'm going to write out equation B, 3x minus y equals 17. And I'm going to substitute now both my value for x that I figured out before and my value for y that I figured out over here. You've got to be very careful here with the negatives. 3 brackets 5 minus, and then y, we can see over here, is negative 2. So I've got to get my brackets there. This is why we say substitution replace with brackets, guys. So this is then 15 plus 2, which is 17, which is what we were aiming for. Well done us. Correct. But look at the strategy. The purple pen is always the same. The things I'm writing in purple are always the same. Pause the video and make any notes that you need to, and press play when you're ready to keep watching. Right, let's do one more example before you do a bit of independent practice. So, let's look at this one here. Again, I want you to solve these equations simultaneously. So pause the video, make sure your strategy is clear, and when you're ready for me to explain how to do it, press play. So, 2 equations, 2 unknowns, simultaneous equations. We're going to draw this out, we write our box over here, and we've got to figure out whether we're going to be adding or subtracting. Before we know that, we have to decide which of x or y we're going to eliminate first. So, remember, we eliminate the one which has the same number in front of it. 2x and 1x, that's obviously not the same number. Negative y, positive y, they've both got a 1 inside. So, how am I going to eliminate the y's? I've got negative 1y, positive 1y. If I try taking them away, I've got negative y, or negative 1y, take away 1y, I end up with negative 2y. That is not good. It's not what we want. So I'll do negative 1y plus positive 1y, and these are the same as adding. Negative 1 plus 1 gives 0, and that was what I was hoping for. So that means in this box, we need to have this plus. So I'm going to write that in, and I'll do all my working in green. 2x plus x is 3x. Negative 8 plus negative 10. If you're not sure about these, write them out nicely. I'll do it over here. Negative 8 plus negative 10, because we've got this, this, and this, equals, I'm starting at negative 8, I'm going down by 10, I end up at negative 18. So I get there. Eliminate the times 3 by dividing by 3 on both sides, and I get x equals negative 6. So that's my solution for x. Subs in. Here's my strategy again, that's why I'm back to purple. I'm going to go for B, looks much easier. So I write x plus y equals negative 10. And instead of x, I'm going to substitute in the value that I got here, which is negative 6. Add 6 to both sides, and I get negative 4. Negative 10 plus 6, starting at negative 10, going up by 6, end up at negative 4. That's my solution for y. Subs in B, checks in A. Subs in B, checks in A. Subs in A, checks in B. We start joining in yet? Hope so. So we write out A, 2x minus y equals negative 8. And I'm going to substitute my two values for x and y, my two solutions. So 2 times negative 6 minus negative 4. Make sure you're writing those brackets there, because these negative signs are going to get tricky. Negative 8 equals negative 8. Therefore, I know I've done it correctly. Make sure you made any purple pen notes that you need to. Press play when you're ready to keep going. All right. I've got 3 questions here for you. I want you to pause the video, have a go at doing these on your own in your book, and press play when you're ready for me to go through how to do them. Okay, so make sure you got your purple pen in your hand. I'm not going to talk through these, I'm just going to write the working. Maybe I'll talk a bit. Positive 3y take away negative y is the same as positive 3y plus y. Negative 10 minus 14, same as negative 24. Subs in A, checks in B. So instead of x, I write 2, and instead of y, I write negative 6. Does it equal 14? Yes, it does. They're correct. Second one. Going to eliminate the x's. Negative x plus x cancels them. Means I've got 11y, and negative 26 plus negative 18 is negative 44. So y equals negative 4. Subs in B this time. X plus 5 brackets negative 4 equals negative 18. X minus 20 equals negative 18. X equals 2. Subs in B, checks in A. Negative the value for x plus 6, and negative 4 is the value for y, which is negative 2 minus 24, which equals negative 26. So I know they're right. And the last one. Eliminating the y's. I have negative 2y plus positive 2y, they cancel. And I've got 10x equals 30, x equals 3. subs in B, because they're all positive. So 9 times 3 plus 2y equals 30. Y equals 3 over 2. That's not very nice, but we'll check it by checking in B. It's possible I've gone wrong. Sorry, checking in A, because I already subbed into B. X is 3 minus 2 times 3 over 2 equals 0, which is 3 minus 3. Yep, 0 equals 0. So I know that y is 3 over 2 and that x is 3. Thanks for watching, and make sure you're taking a photo of your notes so that you're ready to send to me. Now, well, send it on Friday. Take a photo now and send it on Friday, like on your system, like I talked about. All right, bye.